For most of us, it should have been a breeze. So look at it, lead 4 oxide. What's lead symbol?
PB.
I gave you the oxidation number, right? So all you have to do is PB has a 4. Oxide is O. What's its oxidation number?
2.
What should you recognize about 4 and 2 immediately?
Reduce.
It's going to reduce. So you got a 2 and a 4, and you said it was going to reduce. So that's going to reduce into what?
1 and 2.
1 and 2. So PbO2. Nice and easy. Okay? Now, the other one, we're going to write its name. Is it in group 1 or group 2? Is manganese in group 1 or group 2?
Group 1. 2. I mean 2. Group 1 and then first one?
All right. The reason I asked you that is you have to decide if you're going to need a Roman number. All right? Back a couple weeks ago, I told you it needs a Roman number if it does not need a Roman number. If it's in group 1, group 2, or if it's aluminum, zinc, or silver.
It's in group like 7 or 8. Something.
Where is it at? Okay, so is it in group 1 or group 2?
No.
Is it zinc, aluminum,
No.
or silver?
No.
Which means it needs a what? It's got to have a Roman number, which is why I asked that question. So manganese has to have a Roman number. And what is SO4? Sulfate. All right. What Roman number does it get?
7.
That's 7. Came from up there. All right. So if you're in group 1 or group 2, you don't get a Roman number. And what are the other 3 elements that I listed?
Aluminum,
silver, and zinc. Those 3 in group 1 and group 2 get no Roman number. If you're not one of those places, you have to have a Roman number. Everybody remember that?
Yes.
Okay. Now, the next one, write the equation. I gave you an easy equation. Aluminum. How do you write aluminum? Is it diatomic?
No.
You don't put anything on it. Plus hydrochloric acid. How do you write hydrochloric acid? HCl. Yields. How do you write aluminum chloride? AlCl. All right, it's a compound. What do we got to do to it? We got to crisscross, right? Plus 3, minus 1. Where'd those numbers come from other than Miss Wall's brain?
Right.
So what group is aluminum in?
13.
13. So it has what oxidation number if it's in group 13? Is everybody with me on what I'm talking about?
Yes.
Okay, so plus 3. And then chlorine's in group 17, so it's minus 1. So 3 and negative 1. Plus hydrogen. How do we write hydrogen? H2. And we put a 2 on there because it is diatomic. Everybody go with that? Okay.
I think I got it.
Why is it 2?
Because it's for the black pen that I don't have out. So we have 3, but we have,
I got 2.
we're going to need a 6 there.
Yep.
So we need 2 to make 6, 2 aluminums, and 3 there. Everybody go with that?
Yeah.
All right, so the last one is a math. So we need an empirical and a molecular formula. What do we do to find the empirical formula?
Change the moles.
Change your grams to moles. So 75 grams of carbon
Miss Wall,
and 25 grams of hydrogen. Yes.
I know you said that we normally don't even finish all the criteria, and that means we probably won't have a review day for the exam.
We'll take 2 days to review.
Oh, so we'll probably have a review packet, right?
You will have a review packet.
Well, whenever you said we won't finish the criteria, we never do. It kind of worries me that we just be working until the
You will be
exam.
close. You might not know how to answer 2 questions on the exam. 3 at most. Out of 45.
That's not it.
That's crazy. It's really gonna be 45 minutes and doing all this stuff.
Yep.
I thought that should
That's like
have-
a whole test we gave was like, what?
I'm not in charge. They don't tell me.
If you could
I think there should be more questions on the
I was about to say,
exam.
if you could make
And 5 of them are field test items. They won't even count. You just won't know which
That's
5.
how it's on math. There's 34 and there's 4 field tests. So I'm gonna fail.
All right, so what do we do with the moles?
Huh?
I don't know what to do.
Divided by like the smallest.
Divide by the smallest.
I swear.
All right, so when we divide by the smallest, 6.25 is 1. 6.25 is 4. So CH4. This is the what formula?
Empirical.
That's the empirical formula. Okay? Now, from there, I want the molecular formula. So what are we going to do with the 48 that's in the question and the CH4?
Oh, times it by that, right?
You got another step before you times it. You got one more step.
You gotta divide.
You got to divide something.
Oh, you gotta take the mass of that and divide it by that.
Take the mass of 48 and divide by this mass. So you got to divide CH4's mass. So 1, 4, 12, 1, you get 4, you get 12 for a total of 16.
Who doesn't that fast?
Right.
Let me know.
She just did.
What's this for you?
48 divided by 16.
3.
So you did it pretty fast there.
She's
All right, so now we do what you said.
3 times.
And we multiply the 3 times the CH4. So we get C3H12. And that would be the molecular formula. Questions?
No.
Everybody okay with that?
Okay, so also, and both questions. What other major grades are in, like, how many more tests do we have?
At most one.
Praise God.
The only question I still have in my head is whether I'm going to do it benchmark style or these topics that we're doing about next week and a half, 2 weeks.
Probably.
I haven't decided.
Yeah.
I was going to do better.
What's the highest grade?
Remember, tomorrow's the last day for test corrections.
Yeah.
If you wish to do those.
Were you watching?
All right, I'll let you hang on to your calculators while we go over the test and then we'll put them up. That way you don't knock them off your desks all day.
What was the highest grade on the test?
90 something. 98.
They smart.
What's wrong?
No, sorry, but I can't do it all.
Currently, we still have the same policy we had.
Hey.
So if your exam score is higher than your overall average, it still counts 50%. And if it's lower than your overall average, it counts 25. The one I have here. It's because I have more. It's because I have more.
It's my day. I'm such an idiot.
I
got the right thing.
hear that that's changing for next year.
I did the right.
So right now,
I set it up wrong.
it's still the same exam policy that it has been. And if you score higher on the exam than the current average,
There we go.
I didn't even do it. I just had to do
It's okay.
No, that was my second. I was like, what is this?
Nope, for that study.
I didn't get this. I just had a 90. You want to be extra?
I'm really dumb.
I want to be extra. Dude, you like to have one blank. I can't work with blank. I don't know where you want to partial credit on their blank.
I really struggled on this one. I don't know why, but I struggled so hard.
Everything was right. You just calculated it wrong. I don't know where you went wrong with calculating there, but it worked right.
But I struggled, like, I had to read erase,
I like how you chose the first tab.
How many times did you do it?
No, it was only on one question, but I just did the first tab. That was the only thing I got wrong on the math part. That's exciting.
Anybody else have a question? Hey, Bishop, what's up, man? Anybody else not take besides Victory? I know she didn't take it.
What time is it for number 12? I just have
I'm gonna go for summer.
Victory closed door, dude.
Yeah, you have to write letters. They don't have to.
I just need to learn how to write units. I guess.
That's what I need to do. I need to get this out.
Linda wants the answers to the front page. So for those of you who want the answers to the front page, number 1 was C, 2 is A, 3 is C, 4 is C, 5 is A, 6 is D, 7 is B, 8 C, 9 B, 10 is C. What? 7 is B is boys.
Can you tell me why 2 is A and not?
Diffusion is gases that mix spontaneously, right? So anytime the particles are hot or have a higher temperature, they're gonna move faster, right? Now, think about it logically. You and I are in a race. Who's gonna run faster? Why? You're gonna outrun this ball. I got a lot carrying around with me. Okay? You're just gonna go faster. That's just the reality of the world we live in.
So the molecules being large, I figured they were
No, they're gonna slow. You're gonna move as fast as you can.
Yeah.
You convert some of your cube to liters, and milliliters. Some of your cube to milliliters, and then you convert it all. The answer is wrong. You convert it. You should have just left it 175. You didn't need to change it at all. Centimeters cubed and milliliters are the same thing. You did not need to convert it. So your decimals are the wrong place. That's all that's wrong with your answer. Anybody else? Question?
And this one, it was.
You Yep.
I get that though. The one that and that lady.
That blue lady?
Anybody else? Questions before I take these back? Back, let me have it.
Oh, hey, I might.
Happy New Year.
Well, I have to give you a
I think it's missing. There's only 2 things missing.
It's the same.
I was really like.
Okay, I'm gonna send it to them. It's the same ice cream.
No, that is one very
I ate lemon at most. You can go somewhere. I put a bow on.
You too.
Take it away.
It's cheap and simple.
That's what I do. Get $4
One day I just wanna walk past her like nothing. I'm like, oh.
really
And she's like, yeah, you want to get another one? I'm like, absolutely. I don't work here.
All right, somebody let Victory in so I don't leave her out there in the hallway. All right, you guys put your calculators up so I don't have to listen to them hit the floor today. Because we don't need them till tomorrow. We're not going to get to math today.
Again, did you guys tell me ice cream? So I said, we put Allie in water. And Allie, but I she get free.
What's your brand?
No, that'd be nice. Right? Just even pass it.
So we ran out of ice cream like 10 minutes because right now froze. That's how it's frozen.
All right.
It's freezing.
Now
We're going to combine what we were doing in the last unit with solids and liquids. Now, this topic, and really the next test, if I decide not to go the benchmark route, is sort of a hodgepodge topic of several things. So we're going to start with solids, liquids, and gases. We're going to work through their properties. We're going to go into phase changes like today and tomorrow. We're going to bebop over to two types of equilibrium. Potential energy, thermodynamics, kinetics.
Equilibrium.
And eventually, if I decide to test, we'll probably test around there. And then we'll head towards solutions, precipitation, hopefully get to acids and bases. Acids and bases are usually the piece we struggle to get in before the exam, which is why I said there could be 2-3 questions you might not know on the exam, but I'll even give you tips on how to get that.
Talking about me.
Huh?
Like I thought you were talking about like, because whenever I asked you, like, you probably won't know like 3 to 4 questions, but you're just talking about because we won't get to it. You're not saying that you had faith.
You probably
You
will,
got my hopes up still.
No, generally, Annabelle, I don't try to single you out.
No, it's just what I just thought.
So maybe
Well, you think
knowing
on a
that
lot
because
of
you had your
people.
hopes up, Annabelle.
Dang it.
Just know. So, going back to where we were in the last unit, we're still going to be talking about KMT. All right? So, if we're still talking about KMT, when I use that abbreviation, what is KMT? All right, so it's the idea that particles are always doing what? All right, so I'm not writing the whole thing. Particles are always. Now, given that I graded the test by hand, there were very few of us who got this wrong, but there were a few, all right, or about 3 of us who got this wrong. All right, so given that, when I say particles are always moving, what states have motion? All of them, okay? Solids, liquids, and gases. We did not have 100% of us get that question right on the test. I sort of thought we would, but we did not, okay? I know, y'all should feel bad that you did not get that right. Now, so if solids, liquids, and gases all have motion, when did we say in the last unit when we did gases, motion stops? I heard it out there. That's right. Motion stops at absolute 0. Now, given that we're not at absolute 0, which we said was 0 Kelvin, all right, and we're not at 0 Kelvin, all states of matter have motion. Go ahead. All right. So, if I ask this on the next test,
I got it, because I gotta write on this test.
All right, I was hoping that perhaps we'd do a little better. Okay, the next test, if we take it, whether it's the benchmark or the other, let me correct that. Whether it's the benchmark or the other, it will be all multiple choice. You will not have another free response test.
Dang it.
No, I don't like that response.
Multiple choice are hard.
Okay, just saying. I'm done grading free response. All right, so I drew this at some point, but I don't really remember when I drew it. And I don't know if everybody was paying attention when I drew it, because I just sort of assumed that people remember this from other science classes. And I should probably never make that assumption. All right. But at some point in your previous science background, someone should have drawn for you a picture of a solid, a liquid, and a gas.
Yeah.
Literally, what I
Okay.
was in 8th grade is the freaking water cycle.
You do it on the line.
I know, I drew it on the whiteboard. And I don't remember if y'all put it in your notes or whatever. Okay? So when we were talking about the motion of a solid, liquid, and gas, all right, I think it was Alondra who came up and asked me a question about the motion of the solids, liquids, and gases when we were doing the review. So I want to go back and touch on that and make sure everybody's clear on what types of motion they have. All right, so a solid, all right, looks like that. A liquid
Looks a little like that.
all right, because this is going to be important when we get down there and we talk about the properties.
Your solid circles look like tomatoes because you didn't connect them.
Oh. One of the review questions on the multiple choice paper said something about, did they have different or same masses? And I can't remember which question it was. I might be able to find it. A lot of y'all picked the one about mass.
Probably.
Look
at the last one.
I think it's 4. The most significant difference between gases and liquids, you guys pick the mass of each particle. All right. Now, look at the way I drew the particles. All right.
They're all the same size.
That's right. All right. I drew them the same size to try to illustrate that is mass different in any of them?
No.
No. So let's assume for a moment that this is water. Okay. Just because everybody in here is familiar with what happens when we change water in their states. All right. So this one, let's just say is ice for a moment. This one is plain water. And this one is steam.
Steaming.
Okay? So this is the solid state of water, the liquid state, and the gaseous state. Everybody in here has been exposed to an ice cube, water running out of the faucet, and steam above the pot. All right? Is the size of the water molecule or the mass of the water molecule going to change?
No.
No. What's the formula for water?
H2O.
If you add up its mass, how many O's do you have?
1.
How many H's?
2.
Times its mass of 1, times its mass of 16. You get 2, you get 18, you add it up. Whoops, sorry, can't multiply, I'm already adding. 2 plus 16 is 18. All right, so the mass of a water molecule is 18. All right, it doesn't matter if it's solid ice, if it's liquid water, or if it's gaseous water. Okay, the mass of a water molecule is 18. Doesn't matter the state. So I tried to draw them in equal masses to illustrate that. Okay, the only difference that makes a solid, a liquid, and a steam different is how much what is between the particles. Space. Okay, the amount of space
I don't remember, I forgot that word wrong.
makes them different.
Wasn't that a question on our review?
Yes.
Yep, I just said that. I read the question off the review sheet. Were you not listening to me?
Oh, I thought that was the test question.
I may have had it on the test.
I think it was the test question.
But it was also off the review sheet. There were several test questions that people got wrong that were off the review sheet.
I think it was
Okay.
that was.
But that's how we change from states is the amount of space.
Is
Okay?
that supposed to say state? Is that supposed to say?
Yes, it is. States. Thank you. I said states and wrote space.
Silly.
Now, what kind of motion they have is what we're getting ready to talk about in a chart. All right. Yep. We're gonna make a chart. Yep.
Okay.
All right. Everybody caught up with me? Everybody got what they need off this board? All
I
right.
have a picture of that on my phone somewhere.
I'll just leave that there. No, I won't use this. Let's go with motion, arrangement. Attractive force.
Okay, I'm gonna wait till you finish drawing this. because-
Put state there. All right, let's do gas first because you know that one. We'll do liquid second.
Better not be wasting time.
And we'll do solid last. All right.
Okay, done?
I'm done. It doesn't look very good, but that's okay.
We're gonna go.
You still got a calculator.
You took care of those.
Take care.
Oh, yeah, she is at her.
Do you think?
All right, we caught up?
No, really? You talking about this? Yeah. Yeah, I'm sleeping and go like this. Big up. Like she ain't nobody. Yeah.
I know, that's what we said earlier.
Right, Kevin, you don't look this far. She be talking.
She was making fun of me.
Thank you for returning.
Why not? Yes,
All right, we caught up now?
No.
It doesn't have to be a work of art. All right, so tell me about the motion of a gas. How? A lot. Why would it move a lot? The particles are what? Are they close together or far apart? All right. So, all right. So that since they're so far apart, they're able to vibrate, rotate, and translate. Okay? And they move very quickly. All right? They're able to move very quickly because they're very far apart. It's sort of like right now, if I sent Nadia to the main office, all right, and she walked up the main hall, would anything get in her way right now? Air. There might be a couple people on the hallway, but she'd be able to avoid them pretty easily. Now, what if I send her at the change of class at 11:40?
It's gonna take a minute.
It's going to take a little bit. A bunch of people in the way. Okay? Now, at the change of class, it would be more like the liquid state. Could she get from here to the main office?
As fast, no.
No, not as fast, but she could get there. She'd just have to weave her way around people and probably do what? Bump into some people periodically, right?
Like, move.
Might have to say move. Now, so for the liquid, to compare that, the liquid state
Oh my gosh, I wrote the wrong ones.
is much closer together, all right?
Who writes gas, liquid, solid? It's always solid, liquid, and gas. Like, oh.
All right? Now, because they're touching but able to move, liquids are also going to vibrate, all right? They're going to rotate, and they're going to translate, but they're going to be much slower. They would be much slower because the particles are so much closer together. Okay? Now, I skipped attractive forces. What attractive forces am I talking about?
The negative and positive thing?
What negative and positive thing?
I don't know.
All right, polar, non-polar. So what polar, non-polar forces did we talk about? They had names. London was one.
The water.
Dipole, dipole.
And the water thing. The hydrogen.
Hydrogen bonding. All right. So attractive forces were, and I'm just going to put them up here. So hydrogen bonding, LDF. You can write them wherever they fit. I just put them up there. Hydrogen bonding, LDF, and dipole, dipole. All right. So our gas molecules that are moving like that are going to have those forces.
So that last thing you wrote, is that?
Are they going to be able to attract one another and stick together?
No.
No.
Not the gas.
So the H2
Not
bond,
very well.
do be like, that's the attractive forces, or we
Those are the three attractive forces. I'm asking, do gases have any?
wrote them in the gas?
I'm just putting them there because I don't have a place to stick them.
So I
You
don't
can
need
put
to
them
write
under
that.
your chart for all I care.
Yeah.
All right, so do gases have an attractive force? All right, none to very weak. Now, the reason I wrote none is what did we say about an ideal gas? Do ideal gases have attractive forces? Anybody
No.
remember? We said no, they don't have an attractive force. All right, that was the assumption we made about an ideal gas, is they have no attractive force. But in reality, do gases have attractive forces? Yes, they do. But they're going to be very weak. Why are they going to be weak? Because their particles are so far from one another, can they actually stick together? Have any of you ever played with magnets before?
Yes.
No,
If the magnets are far apart, can they attract one another and stick?
no.
No. So the gas molecules, if they're really far apart, can they stick to one another? No. Now what happens if we talk about the liquid state? Are their particles close together or far apart? Close together. Are they going to attract one another? Yes, they are. Okay? So here, these will be much, right in blue, like I said.
As well.
Why is
So
it not
those
writing in blue?
H2 bond, dipole to dipole, those are like your typical attractive forces. Those are the options.
Those are the options, yes. Yep, that's the LDF. These will be much stronger because they're closer together. Now, what happens when we become a, that's not the one I wanted. What happens when we become a solid?
Great question.
Very strong because they're together.
All right, their attractive forces are very strong. Why are they so strong?
Because they're so close.
They're attached.
They're basically doing what? They're not attached, they're touching. All right, what can you tell me about their arrangement?
They're close.
All right, I'm going to give you a new word. They're in a fixed geometric pattern. Now, we talked about this before. I have a crystal lattice.
Sorry, I'm
What's not good for your heart?
Monsters aren't good for your heart. It's a stimulant. I love I drink, you know.
Hold up, fellas.
I saw Miss Wallace here, but
How do you crash and burn my thing? I promise you, you be up all day like.
Let's try 405.
apparently it was even shorter when my mom was here.
It's possible.
But she was like had to bang. Well, emo bang.
Well, should I go?
Absolutely.
I think I want the balloon.
I hate the school.
That's nice, babe.
You sound like an old lady.
Okay, to be honest, I think I'd be better.
Only like us.
Brandon,
Sorry. No, but I mean, that's
You sound like you belong in middle school. With that, I hate every day.
Everyone says go Bruce.
Right, everybody, like, you're still gonna get me.
I promise you, Texas ain't moving north. Like you really think it is like.
Him and Ryan would have been
Right. Like they, he's my but I don't love him to death. If he went to North, he ain't gonna be star player anymore because North is known for all that stuff. He's still gonna be dead. I don't know.
You better not. I'm calling his mom.
All right, before I pull up the picture I just found, what's the motion of a solid? All right, very little. So what one will it do? All right.
We really do look like this.
Yeah, that you did.
That's scary.
It will vibrate only. All right. Make sure you write that down because I'm going to pull up the document camera.
Can you read up very little?
Very little and vibrate only.
You had to look it up.
No, y'all just told me my pictures were terrible last time, so I had better pictures. That's all. No, I looked up pictures to show you. I couldn't find the picture I wanted in the other book. Everybody have it? All right, let's see if Patricia feels well today.
Patricia.
Oh, look at her.
And Steven quit. He said he's gonna have the one.
What is that? That's
See if I can.
It's all strawberry.
Why don't I like?
All right, for those of us who got the question wrong on the last test about the crystal lattice and the unit cell, all right, this whole thing is called the what? The whole thing is the crystal lattice. Okay? The whole thing is the crystal
I
lattice.
thought it had to actually look like a crystal.
That would be a cubic crystal.
Oh,
Okay? This in pink is the what?
unit cell.
That's the unit cell. Okay? So if you see one unit cell, you should know all the others are a what? The same geometric pattern as all the rest of those. I cannot draw that on the board, which is why my picture looked like crap the last time I attempted to draw. Okay?
I was confused.
I'm sincerely sorry, but I cannot draw this. All right? So this is, get off my board. Fabulous. That's a unit cell. I need a whole crystal lattice, dude.
going.
All right? So this would be the crystal lattice. The pink is the unit cell. Now, for our solids and our crystal lattices, there are only 7. Let me move this out a little bit. There are only 7 types of crystal lattices.
We gotta learn that.
You do not have to learn this, okay? The one I just showed you is that one. There are 3 you have to know that I'm going to tell you in just a second, okay? Cubic is one of the most common. Tetragonal, hexagonal is one I'm going to make you learn. Trigonal, orthorhombic, monoclinic, and triclinic. So anything that is ionic that we talked about, that's a crystal, has to be one of those 7. There are no others other than those 7. Okay? Now, let's see if. I don't need you to keep going with that. Fabulous. So, there are 3 crystals that I want y'all to know. All right, salt, sugar, and ice?
I,
All right, salt and sugar are both cubic. And those are pretty easy to see. You can see those with a magnifying glass. Some of y'all might have eyes good enough to be able to see those on your own. All right, ice is hexagonal. All right, now the reason that ice floats, and I cannot draw it 3D, I can only show it from one end. Ice, when it freezes as a solid, right? Well, when it freezes in that hexagonal pattern, air is trapped in the center. Okay? So every time it makes a crystal, air is trapped. So if every time it freezes and traps air in the center, okay, what does that do to the volume of the ice? Does it make it a bigger volume or a smaller volume? Makes it a bigger volume, which is on the bottom. All right, the mass becomes a smaller mass. And so when you divide, you get a smaller density.
That's a nice
Okay.
drawing.
That's why, okay, that's why ice floats. Okay? Because the ice, the solid ice, is less.
I feel like we already have a page of notes that's titled Solid Liquid Gas.
All right? Ice floats. The solid is less dense than water. Okay? Because all that air gets trapped in the ice becomes less dense. Water doesn't have that air trapped in it. And so the liquid is going to be more dense, and so the ice will float to the top. It's one of the few liquids that works that way.
It's only 10:50. Oh my God.
Stop whining.
It's only 10.
Are you gonna miss Wikipedia after you? I don't think we're
Am I going to miss it?
Weren't you here?
After I retire?
Yeah.
I don't know.
What are you gonna do after you retire?
I haven't decided that either. All right, does everybody have it?
No.
Miss Wall, how'd you bruise your arm? I meant the other one. I didn't realize.
Oh, I didn't know I had a bruise on both of them. I fell
I
Saturday.
got this. I don't even know where it came
You
from.
feel Saturday?
Yeah,
Wow.
because I'm a giant klutz.
What'd you fall?
That's what I gotta say. If I see you fall, I can't see nobody fall. I laugh every time. I don't know why. I feel bad, but I think it's funny.
It was bad. It was pretty funny.
No, Miss. What's her name? Miss. Yeah, she fell on Jordan. I was
I didn't know I was bruised on both arms though. I only knew one.
Why did you fall?
Into the tomato bed, which we don't use anymore in the yard when I was mowing the grass. I was pulling the lawnmower backwards and I didn't see it.
I would have been.
We have security cameras.
No.
Because I didn't see you just fall right there.
It's a wonder I wasn't spooked by the tomato wires and all that.
How?
I have no idea how I bruised all that. I have no idea. No idea.
Is your butt all bruised?
No, I don't think so. I don't remember seeing any in the mirror, but I sprang up pretty quick because I didn't know if there were bugs, snakes, or what was in that mess. So I didn't lay there long. You'd have thought I was on a spring. All right. I think we're good there. Let's talk about properties. I guess we could do the activity. We got time, I think.
Activity.
No.
No!
Nah. All right.
It is Democrat.
Well, what was it?
I had ruled it out earlier.
Yeah.
Democracy?
Over it.
What day do we not have a AP test?
None.
Because I want to do
So maybe Tuesday.
a lab.
Next Monday.
I think they're all
Not
Tuesday.
Thursday or Friday.
Specifically, I know not Thursday or Friday.
It's on the circuit board.
Psych is it's on Rector's board.
Wait, look,
It's Thursday.
Yeah, I think it's on.
I'm sorry to say y'all.
Just shush, I know.
Right.
I know everything. I need another big grade on here. We need a lab. Let me see your paper.
I just hope it's nothing on eyes. The brain.
Oh, Brandon was guessing? Oh, it's you, Brandon. I got him to dance today. We can do it Monday or Tuesday.
I think that's my new.
Because our topic tomorrow has a lab that I want to do. All right.
No.
I'm ready.
We won't have one.
Don't give me.
I don't think anyone had it on this Wednesday.
Hey, flip back there.
Here.
Yeah, but I'm not sure we'd be ready to do the lab Wednesday after we do the topic tomorrow.
Lab.
Yeah. I want to do a specific heat lab.
Calculus?
I know, we're all juniors or sophomores.
I know.
So why would it be?
I don't know. Get over to.
Yeah, nobody's here.
Okay. So no one has one Tuesday? Next Tuesday?
No, that's why I said we can do Monday or Tuesday.
Give me Geo. Give me Geo next Tuesday. Oh, yeah, no, we can't do that day.
I was thinking Monday. Is anybody on Monday?
No, there's not even an exam on Monday. You could either do it Wednesday, May 8th, or
I was thinking Monday. Does anybody have Monday?
Let's do it Monday.
there's not an exam Monday.
That's why I was thinking Monday. Because we'll be good on Monday. Because we'll teach it tomorrow. We'll practice it Wednesday. We'll have even had a quiz on it, so we should be good by Monday. And then we can do the lab Monday, lab report due Tuesday. If you have
That's a big grade. That'd be great.
if you have an exam on Tuesday, you're gonna have to have it to me Wednesday if you don't show up Tuesday. If you come Wednesday and you don't have it, it's just a letter grade off.
But I know.
I mean, when you return to me on Wednesday, you better have it in your hand.
And we'll be here Monday to do it.
Yeah.
I won't be here with you.
It's due Tuesday. If you're not here Tuesday, then I need it on Wednesday when you come back.
Wait, what if we don't do Wednesday?
You have to have it due Tuesday.
So why
This is
would
not
we
rocket
do that on
science.
Monday, but turn the lab report in on Tuesday?
Yes.
But how does that work?
It's your lab.
It's an easy lab report. You should easily be able to turn it in on Tuesday.
Or it doesn't matter.
Say what?
How are we doing it after the lab though?
You remember the lab report we did last time?
No.
That was like 6
Fine.
long.
Go.
Copied on.
I thought you did that before the lab so we knew what to do though.
Yes, and I'm going to do the same thing.
But we do that Monday.
Yes, you'll have instructions on Friday.
Oh.
I will be.
I'll give it to you Wednesday. It's probably already run off. Let me.
Because
Thursday, we'll have the exam. Friday, I'm go play ball stuff.
Make myself a note to give it to you tomorrow.
Where's the name of
The church, the big church.
That's what you have.
That's what we have. And all you get on
Nobody's
the
giving me the address.
It's the one.
you better look girl, you missed every test year ago.
No.
All right. I run it off tomorrow morning. Remind me to hand it out tomorrow. So those of you who have AP testing later in the week, have it so you can do the procedure and data table so you're ready to go on Monday.
All right.
Okay?
Then we're gonna
That
do
way
it.
nobody who has an AP test later in the week can say, I didn't get it. Okay? Now, this time, if you don't do the assignment for the day of the lab, there is no makeup. Okay? Did you hear me say that? Because about 4 of us didn't do our homework,
You didn't have to.
and I let you come back in and make it up after school. This time I'm giving it to you almost a week in advance, because I'm going to give it to you tomorrow during class, and we won't do it until the following Monday. So if you don't do your homework on Monday when we do the lab, and you're sitting here because you didn't do the pre-lab work, you just take a 0. There's no come back in after school and make it up. Everybody good on the rules?
And what's
It's
wrong
not
with
that long of a pre-lab. There's a few steps. It's about, I don't know, I've broken them apart, so it might be more steps, but the length is about the same.
What's the,
And then there's a data table. I've given you the data table. And then you'll just have to have it ready.
What's the lab on? Is it kind of
It's on
cool?
specific heat.
Is it kind of cool?
No, it's not real cool.
I got a lot wrong on the last one. There was little things, so you can't write in pen.
So you what?
I got a lot of little things wrong in the lab last time, so you can't write in pen.
It has to be a pen.
Has to be in pen.
Oh,
Has to be in it.
maybe there was, okay,
Blue or black.
okay.
Okay? You have the last one, so you can keep looking back at it and not make those same mistakes.
Let me see, but probably so.
Okay? That would be my recommendation, is to look back at it so you can not make those same errors. All right? Now, all right.
Absolutely.
Fluidity. What is fluidity?
Fluid.
I don't know, something for something close.
It's the ability to do what? To flow. All right? Or move. What states have the ability to move?
Liquid and gas.
We already wrote this.
All of
We did.
All right? Liquids and gases have the ability to flow. All right? All of them is a no. Add liquids to what you know. Liquids and gases both have that ability. Oh, why is one over there?
We already
You-
wrote this.
We wrote the definition. Do you know both liquids and gases are fluids? We did not write both liquids and gases in the last unit, which is
I know I
why.
lack some common sense, but I know that liquid is a fluid.
Okay, I'm just checking. All right. Just asking. Evaporation.
Really, I would have done so good on that dang test if I would have like I kept messing
All right.
up.
What does it mean to evaporate?
Good answer.
Liquid gas.
Okay. I would have expected Miss I know the water cycle over there to answer this.
The one thing that I didn't know, but we figured out on our review, was I didn't know that the biggest change was from a liquid to a solid.
Now, if we change from a liquid to a gas, I'm going to specify, and we're going to spend more time on this than you ever wanted to know about evaporation and boiling in a day or two. This has to be a non-boiling liquid.
I swear we learned way more about it in 8th grade year. Like that's all we did. It feels like
All right?
freaking water cycle.
Has to be a non-boiling liquid. When we talk about boiling, we'll talk about equilibrium. So we're not going to talk about boiling until after we learn about equilibrium, because you cannot boil until you know about equilibrium vapor pressure. All right. So evaporation only happens if you're in the liquid state. Being compressible. This is one that often causes issues. All right, which we already defined for Annabelle over here. Being able to squish into a smaller space. Which states are compressible?
It was
That's why I wanted to talk about this.
Yeah.
Gas. Okay? Liquids are relatively incompressible. Okay? The particles are very close together. And because they're so close together, all right, because they're so close together, we say they're relatively incompressible. So for the purposes of asking who's compressible, the only thing that can be compressed is a gas, okay? Liquids cannot really be compressed, all right? Their particles are already so close together, they're not really compressible.
Yeah.
Everybody with me on that?
Compressing liquid, you get it spilled.
Generally speaking, that is correct.
Yeah.
All right. Who has definite shape? This is the one for middle school. We should know this one.
Solid.
Okay. Here's another one you should know from middle school. What is definite volume? What is definite volume? You should have learned these in middle school. If you had a teacher. Okay. Think about it logically then. Think about it logically then. Who do you think would have definite shape?
Solid.
Okay, solid would have definite shape. All right, now think about it logically with volume. Okay, solid will still have the volume. All right. And I hear liquid, you think? Yeah. All right, gases will expand to take up whatever volume they're in. They don't have a definite volume. They will fill the volume of their container. Okay? Everybody good so far?
No, definitely not.
No?
What up, Jake? What's the last?
Miss Wall, do you have any plans for the summer?
To do as little as humanly possible and not break anything.
Annabelle, we not December yet. Come down.
I'm trying to be a summer so bad.
We can tell.
All right?
Wait, when do we get our tickets?
Which state has a definite melting point?
Not gonna ruin my life.
Can I get that cancel cheese? Not for me.
All right, I heard solids on that one.
Boy, that essay had different types.
All right, surface tension. All right, surface tension. What is surface tension? Anybody know?
It's like you can't. How much pressure? Something it takes to come out of the water to come off, something like that. I remember you got it. Something along those lines.
Who would?
I do.
That's what
All right, it's the force that pulls adjacent molecules together. Leave about 2 lines under that, maybe 3 if y'all write really big. I'm going to come back to that one.
What?
Surface tension. I'm going to demo that one in a minute.
You just write it down.
No, because I need to grab the overhead projector and alcohol out of the back room.
Alcohol.
And
Hold
we
on.
get it too.
It's rubbing alcohol. Do not get excited.
Hey, you can still get high off that. You smell it good though.
Okay. I'm a little worried about you.
You're not getting high off rubbing alcohol. I got better things to get high off of. It's not
All
bad.
right, diffusion. All right, some of us had trouble with question number 2 on the last test. What is diffusion? It's the spontaneous mixing of 2 or more materials. Now, what states of matter will diffuse? Gas will. Liquids will. Solids will too. Okay? They all diffuse. Now, based on what we've talked about then, who would be the fastest?
Gas.
Gases will be much faster than liquids. And who will be the slowest then? Solids will be the slowest.
I must be solid. I'm a solid.
All right? Now, solids are going to be the slowest because their particles are in fixed positions, so it's going to be much harder for them to move. Now, really. So if you took 2 metals, for example, and you C-clamp them together, it might take several years, maybe 15, to get them to diffuse, but over time they would diffuse together. Okay? Whereas water and Kool-Aid or food dye, if you put them together, they'll mix within a minute or 2. Gases will diffuse within seconds.
What if like 2 bullets hit each other?
They're probably not going to diffuse, they're probably going to shatter.
I think I
Have
need
you
to
ever
report
seen that
this.
where it's like 2 bullets?
I think I should. That feels safe.
Okay, alright.
Like two metals, like take copper and zinc. Copper's the yellowy brown,
Somebody shoot
and
Hey.
zinc is the
I'm
silver
just
color.
saying it's
You see, clamp those together over a period of years, they will diffuse together.
And then you can't put the bullets on
All right, everybody got it? All right, let's see if I missed any properties. Oh, density.
Be quiet, sit
All right, density.
Swear to God, y'all wouldn't see me no more.
Since they all have densities again, which one has the highest density? It has the highest density. Okay, solids has the highest. Did I skip a number?
No, but that's okay. I didn't even know we were, just.
All right. Who's next? Okay.
We better only have a good 2 more, because we're running out of paper.
I didn't know we were going this far.
And then who will have the lowest?
Yes.
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 Okay. Now, just as a side note, who is the exception that we talked about today?
Somebody.
Steam.
Was steam?
Yes.
Yes. The gas of what?
That's all liquid.
Water.
Yeah, water. Okay.
Oh,
For water,
I said steam.
the liquid was greater than the solid. All right. See if I can grab my overhead projector and my alcohol.
That's all writing you up. I'm gonna report you. Instead of going to the back to get that out. Good.
It's like glass.
I was looking for mine so they charge it.
You get cancer. Go ahead, get drinking.
I haven't seen that.
Look at her, she's got a jug. Dang, this water's like
Miss Wall. What you know?
Miss Wall is wild, dude.
This wall said, let's get lit.
Miss Wall says,
She about
throw it down.
She's about to put that in her biscuit.
What you got in your cup? Yeah.
Y'all know it's not safe to get there. Figure that out.
You know,
Got that
don't worry
lean.
about you people. That's rubbing alcohol. If y'all ever drank rubbing alcohol,
Oh, I have on accident, like, tastes like, nail polish remover, this is what vodka tastes like, so pretty close.
okay, dude.
What do you drink?
Sometimes you need to be drinking strong vodka.
Yeah, like it tastes good.
You gotta mix y'all.
No, but you're just taking a shot.
It don't taste like they're rubbing out.
Y'all, what y'all mixing it with? It's a water. It goes with the heat though. You was trying to dance.
That's my favorite.
Come on. He said I'm gonna give her a big door. Yes, Miss Wall, you got blood for school. There you go, right ahead. What's that? Dinosaur What is that dinosaur? I've not seen one of those birds. Great. I haven't seen that since kids were baby.
I know. I never had an overhead when I taught. I only got one after.
You remember they used to sit on that little rolling car? Yes. Miss Wall, when I was in my mom's yearbook, chair page on her. She stayed out of the prom for 3 hours.
Straight back. Straight back. You're fine.
Well, do you hear me?
What?
Whenever I was listening to my mom's yearbook, there was like a little page towards you because you stayed 3 hours after their prom.
Oh yeah.
And it was like, we love Miss Holslander. She stayed 3 hours after the prom, and you were in like a pretty dress, like a pretty for the 80s. Let's not say pretty, but
Whatever.
her shoulders pooped up. Yeah,
This was style back then.
it was the Rosa style. Whoever did the shoulder pads. They thought it was cute, but
That was back in the day when I did the prom. I've retired from that job. Hey, won't you come on, you stupid board?
Miss Wall, is trying to erase. It's glitching, Miss Wall. He didn't
Cool. All right.
Oh, there we go. Oh my God. What is this? Go back to kindergarten.
All right. So if you look at where I put the water, all right, you see how it has a nice dark spot around there?
Yeah.
All right. That has good surface tension. All right. If you could see the water on the overhead projector, you would see that it's all beaded up and makes a nice round bubble.
Right.
Okay. Now, but because it has this nice dark round circle, it has good surface tension. Now, you can turn the lights off. I don't care. Now, beside it, I'm going to put rubbing alcohol. And this is 100% rubbing alcohol. There's no water in it like y'all buy at the drugstore. Now, look at how flat the rubbing alcohol is. All right, there's no big dark ring around the rubbing alcohol. It's just flat. All right, that has poor surface tension. All right, does everybody see that?
Yeah.
Now, good surface tension, poor surface tension. Now, what's the difference between good surface tension, poor surface tension between the molecules?
Breaking Steven, bro.
You breaking Steven again.
What's the difference? It's going crazy under the paper.
Miss Wall,
Okay, hang on.
the thing with the ring is that water. You know what I'm saying?
The big, yeah.
Let's put it up there.
The thing with the ring.
No, you broke him.
I probably did.
Paul, you just broke Steven again. You broke him.
I may have. Let's hope not. It might kill me.
Trash shot.
No, he's still good. He's still working.
You broke it.
No, he's fine, except I made the eraser gigantic, apparently. All right, so what's the difference between good surface tension and poor surface tension? This is something we've learned this semester. Think about types of molecules and why this one would have good surface tension and this one would have poor surface tension.
Because of the electrons.
Nope, not the electrons.
Ions.
Nope. What? Polarity. All right. So, what kind of molecule is this one?
Pure molecule.
What kind of molecule is this one? That's polar, and this one is what?
Non-polar.
All right. So if we go back where I told you to leave some space for surface tension. All right. So where you left your space for surface tension. All right. So polar molecules have
With the heads. Okay. It's long.
woo.
It seems like you should have left some space.
No, I think
You broke it.
I did too.
What are you writing?
Maybe you can see it.
Kevin may kill me. I think I might have to close this and restart it. All right, polar molecules have good surface tension. So write that because I'm going to have to shut this and restart it. Have good surface tension.
You really thought you were doing something with that paper?
Hey, it works every other year. I've done this every year, and it doesn't break, Stephen. So polar molecules have good surface tension. All right. Non-polar molecules have what? Have poor surface tension. Write that down. All right. So polar molecules have good surface tension. Non-polar molecules have poor surface tension.
Hey. No, I'm serious. What? You better get this paper. I wasn't paying attention. No, you wasn't.
Polar molecules.
Polar molecules have good surface tension.
And the opposite for non-polar.
Okay, so that's all
All right. Let's hit restart and see if that fixes it. It may not. But let's give it a shot.
Great.
Joyce says.
Where'd the rubbing alcohol go?
All right.
Where'd the
While that's doing its thing,
the other
all right,
liquid go?
Right, put it up, put a little bit more.
make sure nothing's touching the board. I don't think it is.
All
right. Now,
Yeah, you gotta.
this goes with something we're going to talk about in about 2 weeks. Move out of the way. All right.
It's gone.
Yes, I'm going to. So here's the water, and here's the rubbing alcohol. So if I add some more rubbing alcohol, notice that the water does not like the rubbing alcohol. And so the water is trying to move away from it, right?
Right.
Now, if I add more rubbing, I think that's the water. That is. All right, if I add some alcohol to the water, all right, the water tries to get away from the alcohol. All right? And if I continue to add alcohol, the water will continue to break apart and try to escape the alcohol.
So how do you get it started together?
Huh?
How do you put it together?
You have to put it in a high-speed blender.
Let's do it. Hey, mix it up. Use your
Okay.
little stir.
But given that water is polar, the polar molecules do not like the non-polar molecules.
Miss Wall, use your little stir and stir it together.
Okay? Questions about
Stir
that?
together. Stir together.
Now, we will talk about this later in the semester.
Stir it up. Miss Wall,
No.
stir it up.
It won't do any good.
We want to see what it looks like.
No, let me start up.
I just stirred it up with my finger. Go sit down.
You're not stirred it enough. What is that?
Look, it makes.
It makes look.
It makes just a little bit.
You
Look
said
at
do
it.
It will, and over time it'll separate.
Ooh, let it, watch it separate.
Right, you know,
All right.
Steven up, so.
All right, turn the lights back on. Let's see if Steven's going to feel better in a minute. Or if Kevin's going to kill him. Kevin, it's the part. He may. All right. Yeah, I do too. What did you
What are you talking about? Did he make it? Yeah.
Oh, wait, no, there's strawberry. You know what? I should saw it.
All right, that took care of that. We did that.
This was this side always done.
Say what?
Is this side of that little binder always done this year?
I know, we're on the third full binder. All right, I think it fixed itself. All right, 2 types of solids. All right, what are the 2 types of solids? All right, the first one is called crystalline. And the second one is called amorphous.
It's one brittle.
Uh-huh.
Oh, yeah.
It is. All right, now that the fans quit, I can unplug this equipment.
So is it good?
All right. Now, a crystalline solid. All right, I need the red one, not the black one. Come back. All right, a crystalline solid has a definite geometric shape and a definite melting point. An amorphous solid has a random arrangement and melts over a range of temperatures. Now,
Hold on.
we want to write down some examples of both. So, ice would be what? Ice would be crystalline.
Sugar.
Okay, something else.
Yeah, what he said.
What?
Salt.
Salt would be what? Okay,
What's those little things you can get from Candy Factory?
Rock candy.
Yeah.
yeah,
That's sugar.
rock candy is sugar. But sure, those are crystalline. Sugar?
See?
I already said. I said that.
All right, can we put some down for amorphous?
I don't think so.
Let's see.
Maybe a.
Wood.
I thought crayon.
No, it's not.
Yeah. What's a crayon made of?
Wax.
Crayon? Yeah. Oh, I was like, that's metal.
A crayon fits there because it's made of wax.
What about a penny?
A penny is an alloy and it's a mixture of metals.
What about paper?
So most metallic bonds are going to fit up here, okay? Just because it's melted and molded doesn't necessarily mean that it's going to fit there,
What
okay?
about paper?
So think about something else that's going to work.
What about paper?
Mostly going to be up there at the top.
Glass.
Glass,
Rubber?
rubber,
Plastic.
at least you participate.
Styrofoam.
Amen to that, Ms. White. Amen to that.
Hey. I'm gonna roll.
I think that's enough for now. We only need 3 for the first one.
So,
How would you say it?
There's another major one I want for the bottom.
Plastic.
Yes.
was it plastic? That was the next one.
Okay, plastic was the major one I wanted for the bottom. All
That's
right,
the next one.
glass, rubber, and plastic are the 3 major amorphous ones that I wanted up on the list, okay? If you hadn't have gotten those, I would have given them to you.
We had
A couple other ones are like tar. Fiber optics right now are one that most people should know because without them, technology would not be where it is today. All right, all of our cable lines run through the ground or through the air. They get us cable networks. We need fiber optics to get those. Without it, we wouldn't have it.
Oh my God.
Those are amorphous solids. Okay. Almost any type of rock that's in the ground is going to fall in crystalline. All right, diamonds, granite, emeralds, rubies, all of those
That's
types
like
of things.
birthstone.
Okay, are going to be in crystalline. Questions about solids, liquids, or gases before we talk about phase changes?
Bro, we got 10 minutes. Just give us the practice worksheet.
I don't have one tonight.
Okay, we don't got homework.
Your homework is to study for what?
Quit.
Bro!
I wasn't aware that I underwent a name change over the weekend.
Be quiet.
I just wanted to know.
The last person who told me to shut up Friday got suspended.
JD? No, JD wasn't. Yeah, but he probably said it in a mean way.
You did.
You know I did it. But anyway.
All right, so we're going to start phase changes. And phase changes is the lab that I want to do on Monday with specific heat.
No, Miss Mark, real quick. So for the quiz tomorrow, it's gonna be on solid liquids gases. Is it gonna be on? Obviously, there's gonna be no math in it, so is it just gonna be like definition type, like crystalline?
Anything that we've done up to this point is fair game for the quiz.
That's stupid because I'm not doing. Is there any math on it?
Have we done any math since we started class?
Well, you said up to this point, so I didn't know it was just today.
What's the major things that's on the test?
What test?
The quiz.
Anything from where you started writing those little solids, liquids, and gases until right now.
I swear, if we gotta fill in this chart, if it's a chart that we have to fill in, I'm gonna be
Right, you be
upset.
asking specific stuff like what if you could find specific what they say, right?
Anything's possible.
If it's that chart and we gotta fill
I
it in,
don't
I'm
want to
gonna
study
be
everything
very
and only a
upset.
small
Okay, then
part.
don't study everything. Don't do it. Okay? It's your call
You're gonna
what you
tell me
choose to
that.
study.
You don't know off the top of your head.
Now, what's a phase?
A state.
Of,
Change.
My email.
you were okay on the state. Of matter. Okay, so what are our states of matter that we're going to work with? Solids, liquids, and gases. All right, so when we say a phase, we're talking about a solid, a liquid, and a gas. Now, most likely in middle school, you talked about 4 of the 6 phases. You might have done 5. There's 6. We're going to do all 6. Okay? Huh? You only thought there were how many?
Just keep going.
Okay. Now, you probably learned the names of them. You might even, for example, be able to tell me that, and I'll just pick evaporation since y'all are so familiar with the water cycle.
Swear.
All right? That you can tell me that it's a solid to a liquid. All right? We're going to be able to calculate the heat lost or gained. Oops, it is. I was doing melting in my, sorry. I was doing melting in my head because that's where I always start. Thank you, Jayla. All right. So we're going to calculate the heat lost and gained. We're also going to read on a graph. And you have to be able to tell me if it is endo or exothermic.
You can take all that.
Okay? So that's where we're going with phase changes in this class. So most of you can probably figure out, like Jayla was like, I thought it was liquid to gas. Yeah, y'all have learned that in other science classes. Most likely, out of the 6, you can all do 4 pretty easily. Okay? Like melting. What's melting? Start as a what and go to a what? Solid to a liquid. Okay? But the vast majority of you probably can't figure out if it's endo or exothermic on your own.
Absolutely.
I know you don't know how to calculate the heat loss or gain, and you probably can't read it off a graph yet. So that's where we're going
We
with
start graphing.
the phase changes. It's one graph. All the graphs work the same way. So once you know the points on a graph, Annabelle,
I mean, in math, we're doing roses.
dude,
Like,
it's a stair step. The stairs either go up or down.
okay.
The points never change on the stairs. They never change. You have to know the points on the stairs, but they never change. The bottom point is a solid. The top point is a gas. Whether it goes up or down. It's not complex like math.
Because now we brought letters into math a long time ago. Now we're bringing flowers into math.
It's not that hard. I I'm easier than math
The
3
rows graphs.
or pre-cal, whichever one you're taking.
Pre-cal.
Okay, it's not that hard.
I hate, yes.
Okay, but I got 100 on my last quiz. I'm so proud of myself.
We don't care since
I kind of cheated because I asked Jordan before it started, but still. Before it started, because I didn't. I just asked her to redefine how to.
It's all good. All right, so tell me about melting. What do you remember?
it's gone.
All right, we all remember that we changed from a solid to a liquid. All right, we gotta expand on that a little bit. All right, so we want to be able to figure out if it's endo or exothermic, right? Now, we should remember,
Is it absorbing?
or,
Release?
okay, so out here to the side, let's just make sure everybody's on the same page. All right, so endo means what again? Endo means what? So heat is absorbed. Okay?
Sit still.
We know. She does that.
All right, so if it's a reactant, if heat is a reactant, it means we're endothermic. Now, exo would mean heat is released. So heat will be a product. So we're going to learn to write equations tomorrow, all right? And if the heat is on the reactant side, then it's absorbed, and it's going to be endothermic. If the heat is on the product side, it means it is released, and it will be exothermic. Are you with me on that?
So you're so nice and so understanding 20 years ago. 20 years ago, you look like you would have stayed more days for test corrections. You look like you would have not used extra credit for bathroom passes. Sometimes you really just got D. And
That rule hasn't changed.
it has.
Maybe she was worse, Annabelle.
I was worse then. I've mellowed.
She was square this wall.
She was with Holslander back then.
I was much harder back then than I am
She was a
now.
what?
Holslander, that was her name.
Wow. What does that mean?
It was her last name.
Oh.
Now she's married.
Oh.
Now,
You just need.
I thought that's what they called her. I was like, what?
I need you to catch it on us.
now the question is, do we need to add heat to change from, this is a solid, right?
You
need to add heat.
How they gonna get the popcorn?
You need to
That's
apply
right.
pressure.
So, do we need to add heat
You need to add.
or do we need to give off heat
You need to
in
add-
order to get those molecules or those atoms to get further apart? Which one has to happen in order to get those molecules to speed up and move farther apart?
You need to add heat.
Okay, Nakai's with me. She wants us to add heat. Okay? So this is what you want to think about in your head. All right? We want
Need some-
the molecules to spread out. So if we want them to spread out, what do we need to do? We need to add heat. So if I need to add heat, what side does it need to go on? Does it go on the reactants or does it go on the products if I need to add the heat?
That's a great question.
We're going to add heat here.
All right. Don't you feel like
Okay.
what she said?
No, we could, but we're not going to because we want to see what side it's on in terms of endo and exo. Okay? Now, I'm going to save these so I have these same notes, all right, for tomorrow. We can come back to them. Your only homework is to be prepared if we have a quiz tomorrow. If you're not here because you have AP testing, watch.
Trying to throw it with it.
Make sure you're caught up. If you don't watch and don't catch up, don't come back and complain the next day. And don't tell me I had AP testing and I'm not prepared. That's not my problem.
That's probably exactly what I'm gonna come and say.